Okay, this is going to be fairly quick on adding and subtracting polynomials. We have done this quite often when we are combining like terms. There's some vocabulary I want you to specifically pay attention to here. You have a polynomial, which is a monomial or a sum of monomials that forms an expression. If we have a monomial, right in here, a monomial means one. It's a single term. So a polynomial is made up of a bunch of single terms that are added and subtracted together. If it's not added or subtracted, then it's a single term. Single terms are products, a number, a variable, anything that is like these that we have 2x to the second, 3x, or negative 5. We do have some special names. If you have two terms, then you have a binomial. Three terms, you have a trinomial. So if we look at 1, 2, 3, and 4, we have some examples there of the specific vocabulary. If you look at number 1, you have 2x plus 3. Your terms are 2x and 3. And it's a binomial because bi means 2. So we have two terms and a binomial. A trinomial, number 2, 3y to the third, 4y, negative 12 are our terms. Trinomial is our name. Notice that if it's minus 12, that you have a negative 12. Okay, number 3, there's no addition subtraction. So this is just a monomial. Mono means 1. And then we've got our polynomial. If it's more than 3 terms, poly means many, so we have polynomial. And I kind of messed up my N and M there, but it's P-O-L-Y-N-O-M-I-E-L. So my terms, 3t to the fourth, negative 5t to the sixth, negative 4t, and 2. We add and subtract those together, we come up with a polynomial. Okay, these are the parts that we've already talked about before. Like terms. Like terms have the same variable and the same exponent and letter. So if you look at your examples here, 5 is like terms, 7 is like terms, 8 is like terms, but 6 is not like terms because we have x to the first and x squared. So we couldn't do anything with those terms. A few examples down here of what we've done before. When we're combining like terms, they've just set these up with the polynomials. And so instead of just combining like terms, we say, okay, we have 2x plus 3, negative 4x plus 5. Put our like terms together. Combine our x's, we get negative 2. 3 and 5, we get 8. Same thing here. Combining like terms. If there's something that cannot be combined, you simply leave it. Here we can do our x squareds. Remember, this is a negative. Negative 8 goes with positive 6, gives us negative 2. 7 minus 12 is negative 5. Here we have a negative 2x that cannot be combined with anything. Simply has to stay as it is. And on 12, we can put 8x and negative 9x together and get negative 1. Negative 7 with 4 and get negative 3. And our x squared term cannot be combined with anything, so we're simply going to rewrite it, but we want to put it in the front. Because normally when you see answers, they're written in terms of exponents from the largest to the smallest. So we have our x squared, x to the first, and this would be x to the 0, but we don't have it written. Okay, even when we get to more complicated problems, just leave it on here so you can look at this one. Sometimes you can write it in a numerical or a vertical form. Notice here, this one does not have an x to the fourth, so I'm going to write an x to the fourth here. Use my pen so it doesn't stick out as much. So I can use x to the 4. We have negative 2x to the cubed, x squared. We don't have x to the first, so I'm going to put a 0 and 3. I can line these up underneath it. Some of you may like to do it that way. Some of you may want to just combine like terms the way we've done before. So we put our like terms together, whether vertically or otherwise. We end up with 9x to the 5th that can be combined. We have a 5x to the 4th, negative 2x to the 3rd. Our 6x squared minus 7x squared is negative 1x squared, and 3 and 6 gives us 9. So that's our answer. And I did the same thing on 14. Combining the x to the thirds, and I go through and mark them out as I go so I can tell which ones I'm putting together. 2x squared, doesn't have anything to combine with, I rewrote it. Right here, it's 2x squared. Combine my x's, get negative 17. 3 plus 7 is 10, minus 1 gives you 9, gives you positive 1. Okay, these are two I want to really focus on. We had a problem with this combining like terms before. You need to pay really close attention to the fact that if you subtract polynomials, you may find it easier to add the opposite. What that means is if we have a negative here, we've talked about before, it's going to change the signs of everything inside. So if this was positive, now it's negative. Positive, negative. Positive, negative. Excuse me. Because you're multiplying through by negative 1, which changes the second ones. Once you've changed your signs, you're just combining like terms like you normally would. 9 minus 2 is 7x squared. Negative 3x minus 4x is negative 7x. And 7 minus 6 is 1. Same thing here, change your signs. Negative times positive is negative. Negative times negative is positive. Negative times positive is negative. Combine your like terms. 4x to the 5th plus 5x to the 3rd minus 9x minus 5. So here, changing our signs is going to be the most important part of adding and subtracting polynomials, just as it's been with combining like terms all along.